Hey kids! Welcome back to our tutorial video lesson with Sir Collin. We are now on our third week of our grade 5 competencies, and for this week, we will be discussing module number 7 and module number 8 of your book 1 in Mathematics 5. For module number 7, that is about the real life problems involving GCF and LCM. So before we will start our lesson for today, I want you to take out your math notebook and let us have the review on how to get the GCF and LCM. For our first activity, our review activity, kindly complete the table by filling out the GCF and LCM of the following numbers. For number 1, 2, 8, and 40. What's the GCF of 2, 8, and 40? Kindly write your answer here. And after that one, you also get their LCM. So kindly write your LCM here. So I will give you time to do this one. Copy this in your math notebook and let us now answer your first activity. For our review activity, you are asked here to get the GCF of 2, 8, and 40. At the same time, you are also asked to get the LCM of the same set of numbers. And how do we get the GCF and LCM of any numbers? So, in getting the GCF and LCM of any two or more numbers, you are to use different methods. The first method is listing method, wherein you will list down the factors of 2, you will list down the factors of 8, you will list down the factors of 40. After na nakuha nyo na po yung mga factors ng mga numbers na ito, all you have to do is to look for their common factors. Ano po yung factors na makikita mo sa 2, makikita mo sa 8, at makikita mo sa 40? So after that one, if you already have the set of factors which is common to all of them, the next thing that you have to do is to look for the greatest. Ano po yung pinakamalaking factor na makikita mo sa 2, makikita mo sa 8, at makikita mo sa 40? That's what we mean by greatest common factor using the listing method. The same thing with the list common multiple. Using the listing method, you will have to list down all the multiples of 2, all the multiples of 8, and all the multiples of 40. After you already have the multiples of these numbers, you will look for their common. Ano po yung mga common na mga multiples ng 2, 8, at saka 40? The next thing that you have to do is to look for the least, the smallest, yung pinakamaliit na multiples ng mga numbers na to kung saan nagtagpo or nag-meet po ang mga numbers na ito. If you will skip count by 2, skip count by 8, and skip count by 40, to which number, what is the first number or the smallest number where these numbers meet? Ano po yung pinakamaliit na number na kung saan nag-meet po or nagtagpo ang 2, 8, at saka 40? Anong multiple? So that's what we mean by least common multiple. The next thing that the next method that we have to use is method number 2. You could also use the prime factorization, wherein you will get the prime factorization of 2, prime factorization of 8, and prime factorization of 40. This is also applicable both for GCF and LCM. All you have to do is to look for their prime factorizations. Then after that one, you will get their common factors, common prime factors. Kung ano po yung common prime factors na makikita mo sa 2, sa 8, at saka sa 40, you will have to multiply them if you already have the product of the common prime factors, then that's what we called already the GCF. Now, for LCM po, kukunin nyo lahat ng mga common prime factors ng 2, 8, at saka 40. After you already have the common prime factors, idadagdag nyo po, you will add all other factors which are not common to these numbers. So lahat po ng hindi common factors idadagdag sa common factors, then that would already be the LCM of these numbers. I already gave you examples before in my previous video. You could review my previous video in my YouTube channel for you to be enlightened on how to use the prime factorization in getting the GCF and LCM. For now, I will be using the continuous division in getting the GCF and LCM of 2, 8, and 40. We do have three popular methods. The first method, once again, is listing method. The second one is using the prime factorization in getting the GCF and LCM. And this time, we will be using the continuous division. How do we get the GCF and LCM of 2, 8, and 40? I will show you this time. It is very obvious that 2, 8, and 40 are divisible by 2. So you divide them by 2. So 2 divided by 2 is 1, 8 divided by 2 is 4, and 40 divided by 2 is 20. After you already have the first factor, now if you will try to examine 1, 4, and 20, there is no more other factor that could divide the three of them except for 1. Now, what will happen if we still insist to divide them by 1? Ano po yung mangyayari pag dinivide pa natin sa 1 ang mga numbers na to? So 1 divided by 1 is 1, 4 divided by 1 is 4, and 20 divided by 1 is 20. That would yield the same quotient. So it's useless to divide them by 1 because pareho lang po yung mga numbers na nakuha natin up to this level. So we need not to further divide 1, 4, and 20 by 1. We will just divide them by any prime number. Kahit hindi po prime numbers, okay lang as long as these three numbers could be divided by that particular factor or by that particular divisor. So for now, we will stop it here because there's no other common factor than 2 which could divide this set of numbers. Going back, it simply means that because there's no more common factors to the three of them, so therefore this is the GCF of 2, 8, and 40. And that will be your answer for number 1, their GCF is 2. For the LCM, we could continue this process in order for us to find for the LCM of this set of numbers. And with that, 4 and 20 both can be divided by 4. This is what I'm telling you before na kahit hindi po prime yung i-divide natin, okay lang as long as pwede nating i-divide yung mga numbers natin dito. So in this case, 4 and 20 both can be divided by 4. So all we have to do, 4 divided by 4, the answer is 1. And 20 divided by 4, the answer is 5. Now, because 1 cannot be divided by 4, or it is not enough to be distributed or to be divided by 4, so we will just copy 1. So, these are the remaining numbers that we need to work with, 1, 1, and 5. However, we have to follow the rules for the LCM that kung meron po tayong dalawa or mahigit pa sa dalawang numbers na pwede nating i-divide, we will still continue on dividing. However, if we only have one number na pwedeng i-divide lang, so we could have the option to stop there. Okay? However, if you really wish to divide, you may continue. You can still divide this one by 5. So, if you already reach 5 divided by 1 is 1. If you already reached that your quotient is 1, 1, and 1, so you stop there. So, here's the LCM of this set of numbers 2, 8, and 40. That is 2 times 4 times 5 times 1 times 1 times 1. However, if you multiply a number by 1, the answer would still be the same number. So, you could simply just stop here. So, that is 2 times 4 times 5. 2 times 5 is equal to 10 times 4, that is equal to 40. Multiply it by 1, that's still 40. Therefore, the LCM of 2, 8, and 40 is equal to 40. That's the smallest. Yun po yung pinakamaliit na multiples kung saan magtatagpo si 2, si 8, at saka si 40. The smallest number where these three numbers will meet. Okay? So, their LCM is equal to 40. Going back to our discussion, how about if you stop to this portion or to this part? Going back to my statement previously that we need two or more numbers na pwedeng i-divide by a prime factor kahit hindi prime factors as long as two or more, dalawa or mahigit pang mga numbers na pwedeng i-divide, you continue on dividing as long as we are just only getting the LCM. How about pag meron ka lang isang number na pwedeng i-divide? For example, iisang 5 lang pwede nating i-divide. This one cannot be divided by 5 and this one cannot be divided by 5. So, what will happen? Will you stop there? So, if you will stop there, you will end up with the same answer. So, if you will stop there, your LCM is here. Lahat po ng number na parang naka-letter L, nasa letter L, yun po yung LCM. Yung parang nasa letter L na to. Okay? So, all you have to do is to multiply these numbers. And if you notice, those numbers are 2, 4, times 1, times 1, times 5. The same kanina na 2 times 4 times 5 times 1 times 1 times 1. So, what I'm trying to say here is, kung nag-stop ka dito, it's still okay. If you don't want to waste your time, sabihin mo, okay, anyway, iisa lang naman yung natirang number na pwedeng i-divide sa 5. So, I will just simply stop there and here's my LCM na. So, that is 5 times 2, that is equal to 10, times 4, that is equal to 40. So, that would yield the same answer, which is equal to 40 for the LCM. Let us now continue with number 2. In our number 2 here, you are asked to get the GCF of 8, 16, and 32. It is advised na yung gagamitin po nating number dito for continuous division should be a prime number. Example, 8, 16, and 32, they are divisible by 2. So, 8 divided by 2 is 4. 16 divided by 2 is 8. Then 32 divided by 2 is equal to 16. However, sometimes, hindi naman kailangan talaga na prime number lang yung gagamitin natin dito. As what I have told you a while ago, pwede naman nating i-divide yung mga numbers dito to a number which is not prime as long as they are all divisible by a particular number. So, for example, 4, 8, and 16. They are all divisible by 4, and 4 is not a prime number. However, if you will divide 4 by 4, the answer is 1. 8 divided by 4, the answer is 2. And 16 divided by 4, the answer is 4. Pwede din yon, as long as pwede. Now, this one, we don't have any more common factors to the three of them, so we will stop there. This is already the GCF of these numbers. You might be asking, sir, yung 2 tsaka 4, they are also divisible by 2. Pero yung 1 hindi. Dapat when we say greatest common factor, lahat sila. You could divide all the numbers by a particular number. Okay, by a divisor. So, in this case, pwede nga sa 2, pero yung 1, hindi natin pwedeng i-divide sa 2. So, we will just stop there. So, our GCF is 2 and 4. And what we will do with 2 and 4 is to multiply. To get our GCF, that's 2 times 4, which is equal to 8. So, their GCF is equal to 8. Okay? So, this time, in getting the LCM, as what I have told you a while ago, we will continue on dividing until we reach 1, 1, and 1. Or until we reach our quotient, all of our quotients are 1. Okay? Or, we will just stop if we have only one remaining number that could be divided by a divisor. So in this case, meron pa tayong dalawang number na pwedeng i-divide. So because we are now looking for the LCM, continue lang. Continue. Divide by 2. So if you will divide this by 2, the answer is 1. If you will divide this by 2, the answer is 2. Then, yung hindi po pwedeng i-divide, you just bring it down. So, our quotient here is 1, 1, and 1. Now, as what I have told you, pwede ka pang mag-continue until na ma-reach mo yung 1, 1, 1 na quotient. Or, kung meron ka na lang isang number, na pwede pang ma-divide, so isang number, one remaining number, then you could simply stop there. At ito na yung LCM mo, yung parang nasa letter L na ito because we are getting the LCM lang naman. Okay? So ayan, yung parang nasa letter L na yan. Okay? So that will be our LCM. You multiply all the numbers inside this letter L. Okay? So, yung 2 and 4 kanina na 8 is the GCF. Multiply it by 2, that's 16. Multiply it by 2, that's 32. Multiply by 1 and by 1, that's still 32. So, therefore, their LCM is equal to 32. Ito yung kauna-unahang number, pinakamaliit na number na pwedeng mag-meet si 8, 16, and 32. Again, I would like to emphasize that when we say GCF, that is the greatest common factor. It simply means pinakamalaking number na pwedeng ma-divide sa lahat ng mga number na to. Ano yung pinakamalaking number na pwedeng ma-divide sa 8, 16, at 32? Now, when we say LCM, ang pinakamaliit na number na magtagpo ang lahat ng mga numbers na to if you will skip count by 2, by 8, and by 40. The smallest number where these three numbers will meet. So 2, 8, and 40 will meet at 40, 8, 16, and 32. That's the smallest number, the first number where these three numbers will meet. Now let's proceed to item number 3. For the GCF and LCM of these three numbers, they are divisible by 2. So this will give you 9. If you will divide by 2, this will give you 8, and this will give you 36. In this case, we don't have other numbers or other factors, prime factors, na pwedeng may divide sa kanila, so we will just stop there. So their GCF is 2. Yun po yung pinakamalaking number na pwedeng may divide sa 18, 36, and 72 evenly. Okay? Now, because we already identified the GCF, so this time, you could continue dividing, or you could still use this method, continuous division, in order for you to arrive for the LCM of this set of numbers. Okay, now if you notice, number 8 and number 36 are divisible by 2. So you divide them by 2, that will give you 4, that will give you 18. Okay? Now, because 9 is not divisible by 2, so you just bring down 9. If you notice, yung 4 still, at saka 18, still divisible by 2. Okay? So 4 divided by 2 is equal to 2, and 18 divided by 2, that is equal to 9. You just bring down 9 because that's not divisible by 2. Now, in this case naman po, yung 9 tsaka 9, obviously, they are divisible by 9. But 9 is not a prime number. It's still okay, it's just okay. So all you have to do is just divide 9 and 9 here by 9. And the answer is 1. Copy 2 and bring down, 9 divided by 9 is 1. Now, up to this point, iisa na lang po yung natitirang number na pwede nating ma-divide by 2. So if you decide to divide this by 2, you will already reach your 1, 1, 1 quotient. So that's already your LCM, yung mga numbers lahat dito. However, if you will just simply stop there, kasi iisa na lang yung number na pwede nating i-divide, so pwede na rin yun. So here's your LCM. Okay? So the LCM is 2 times 2 times 2 times 9 times 2. Okay? So 9 times 2 is 18. 18 times 2 is 36. 36 times 2 is 72. 72 times 2 is 144. So the LCM of these numbers 18, 16, and 72 is equal to 144. Yun po yung pinakamaliit na number. The first number and the smallest number na first na mag-meet itong 18, 36, and 72 if you will skip count by 18, by 36, and 72, or you will get their multiples. At ito naman po yung pinakamalaking number na pwede nating mai-divide sa kanilang tatlo. So that's what we mean by GCF and LCM. You could continue on answering number 4, number 5, and number 6, and you could check your key to the answers at the last portion of your module in order for you to check your answers for 4, 5, and 6. I will leave to you this activity, getting the GCF and the LCM of these numbers using the continuous division for you to practice. Out of that review activity, I hope you are all refreshed now on how to get the GCF and LCM of 2 or more numbers. At this point, one of the challenges po in GCF and LCM is the word problem. This time, it's very difficult to determine or to identify when to use GCF or LCM. For example, we do have here a problem. And let us now check if this problem is about GCF and LCM. Our problem is, a buzzer sounds every 15 minutes. Another buzzer sounds every 45 minutes. If both buzzers will sound together at noon, what time will they buzz again together? This time, let us identify. Shall we use GCF or LCM in this kind of problem? In order for us to solve this kind of problem, of course, we will always have to consider the Polia's 4-step plan in solving problems. And that 4-step plan includes understand, plan, solve, and check. Of course, in order for you to know what's the best solution for the problem, let us follow the steps. First is to understand the problem. And for us to understand the problem, we have to know what is asked in this problem and what are the given. In this problem, what is asked is the time that these two buzzers will buzz together. Again, the time that they will buzz together. The time that they will buzz together. And of course, our given here are the following. 15 minutes for buzzer 1 or the first buzzer. 45 minutes for the second buzzer. And remember, we could also consider at noon here as another given, the fact that they sound together at noon, which also means 12 noon. Let us now proceed to step number 2, which is we need to plan what's the solution for this problem. And let us consider our problem that we are looking here for the time where these two will buzz together after 12 noon. So remember that the next time buzzer 1 will buzz again is 12:15. But the other one, buzzer number 2, will buzz at 12:45. What time will these two buzzers buzz together? So remember that a while ago, I told you that if we are looking for the time where these 2 or more numbers will meet, we are looking for the LCM of these two numbers. It's somehow we are looking for the time where these two will buzz together after 12 o'clock. So we are looking for the time, the next time that these two will buzz. So we are looking for the smallest time or the least time where these two 15-minute buzzer and 45-minute buzzer will buzz together. So I think this problem is about LCM. So we already identified what's the best solution for this problem, which is about LCM. So we will solve now, which is the third step. Look for the LCM of 15 and 45. Because our given here is 15 minutes for buzzer 1 and the other buzzer is every 45 minutes for buzzer 2. Remember that if you are looking for the LCM, ano kaya yung mga numbers na pwedeng ma-divide sa 15 and 45? Obviously, they are both divisible by 5. And 15 divided by 5 is 3. 45 divided by 5 is 9. Next thing is, still, both number are divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Remember I told you that we need to have 2 or more numbers so that we could continue on dividing this set of numbers. However, in this case, iisa na lang. We only have one remaining number that could still be divided by 3. Okay? So you can continue still by dividing it by 3, and this will become 1. 3 divided by 3 is 1. However, this one could not be, or it's not divisible by 3, so you just copy it. So, if you already reached that your two numbers here, puro na silang 1, so here's your LCM this time. You multiply 5 times 3 times 1 times 3 times 1 times 1. And 5 times 3 is 15. 15 times 3 is 45. Times 1 is 45. Times 1 is 45. So, after 45 minutes. So, it simply means that if they buzz together at 12 noon, the next time that they will buzz together is after 45 minutes. So, that is 12:45 p.m. But let us also emphasize that it should be p.m. 12:45 p.m. is the next time that they will buzz together. It should be p.m. because afternoon time is already afternoon. So, let us check if our answer is correct, which is step number 4. For step number 4, let us check. If you will skip count by 15, so if they buzz together at 12 o'clock, the next time that buzzer 1 will buzz is 12:15. Next is 12:30. Next is 12:45. However, our buzzer number 2, because it buzzes every 45 minutes, if it buzzes at 12 o'clock noon, so of course the next time that it will buzz is 12:45. Therefore, the smallest time that they will buzz together is after 45 minutes, which is 12:45 p.m. after 12 noon, that these two buzzers will buzz together. Let us now proceed to our problem number 2. And our problem number 2 is, Danilo, a school varsity player, has 32 pairs of socks and 16 pairs of shoes. He wants to sell a package of shoes and socks. What is the greatest number of packages that he can sell with no remaining pair of shoes and socks? Of course, let us always be reminded and be guided in solving the problem by this 4-step plan of Polya. So the first thing that you have to do is to understand. And in order for us to understand the problem, let us always know what is asked and what are the given and how will we able to arrive with the answer. The next thing that we have to do is to plan. When you say plan, you are trying to consider what's the best strategy to use in order for you to answer the problem. How do we attack the problem? That's how we plan. And of course, to solve, let us always be reminded that this time you will have to carry out the problem until you arrive with the answer. And finally, to check, let us be sure if our answer is really correct or not. So, that's how we check our answer. And with that, in this kind of problem, let us first think, how do we solve this problem? Let us know what is asked. And what is asked in this problem is the greatest number of packages that Danilo can sell his shoes and socks without remainder. It simply means that wala pong may matitira na socks, wala pong may matitira na shoes. So, our given here, 32 pairs of socks and of course, 16 pairs of shoes. And of course, in attacking in solving problems about GCF, let us also be very keen in observing the word clues. We are to divide these 32 pairs of socks and 16 pairs of shoes in packages or different packages. Of course, if we are to pair these 32 pair of socks and 16 pairs of shoes together in one package, there should be no remainder. Wala pong may matitira na socks tsaka shoes. So, we are looking for the biggest number where we can divide this 32, which is also 16 is divisible. because we are looking for a number where these two are divisible, then we are looking for their factors. And because we are looking for the greatest number that where we could divide this 32 and 16, so yung hinahanap po natin yung pinakamalaking divisor, pinakamalaking factor. So we are looking for greatest common factor. With that, we are very confident that in order for us to attack this problem out of the planning stage after understanding the problem is GCF of this 32 and 16. So we are already done with planning stage. We already identified that in order for us to solve this problem, we need to use GCF of 16 and 32. So let us now solve or carry out the problem until we arrive with the answer. Solve. So look for the GCF of 16 and 32. So in order for us to get the GCF, we will use this time continuous division. So what number that could divide both of them? So both numbers are divisible by a prime number 2. So 16 divided by 2 is 8. 32 divided by 2 is equal to 16. Next, both number could still be divided by 2. So 8 divided by 2 is 4. 16 divided by 2 is 8. Still, both two numbers could be divided by 2 again. So let us continue until we end up with 1. So 4 divided by 2 is 2 and 8 divided by 2 is 4. Now, in this case, both numbers are divisible by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So you already have here 1 as one of our quotient. However, 2 here could still be divided by 2. Remember that if we are doing the GCF, it should be both or all the numbers should be divisible by a divisor. In this case, only 2 can be divided by 2. And 1 is not divisible by 2 anymore. Therefore, we will stop there because we are looking for the GCF. Okay? So, here's the GCF of 16 and 32. That's 2 times 2 times 2 times 2. So, we have here 2 times 2 times 2 times 2. So, 2 times 2 is equal to 4. 4 times 2 is equal to 8. And 8 times 2 is equal to 16. So, their GCF is 16. So, it simply means that the biggest package or biggest number of package that Danilo could make is 16. 16 packages wherein each package could have 60 or 32 divided by 16 is equal to 2. 2 pairs of socks. And 16 divided by 16, which is the GCF, is equal to 1. 1 pair of shoes. So, 16 packages with 2 pairs of socks and 1 pair of shoes. So, that's the answer for our problem. What is the greatest number of packages that he can sell with no remaining pair of shoes and socks? So, the answer is 16 packages. Let's try to check. Actually, 16 and 32 are also divisible by 2. However, if you only have 2 packages, that's not the biggest package that Danilo could make. 16 and 32 are also divisible by 4. Both are divisible by 4. So Danilo could also make 4 packages. Now, he could also have 8 packages. However, the biggest number that could divide 32 and 16 is 16 because we are looking for the greatest number of package. Let's try. 32 divided by 16, that's 2. That's divisible. No remainder. 16 divided by 16, that is equal to 1. That's divisible. No remainder. Therefore, that's the biggest number that we could make, and that really makes our answer concrete that that is correct. GCF of 16 and 32 is equal to 16. Therefore, 16 packages. This This time, let us do the page 7 of your module, which is what I can do activity. However, if you don't have with you your module, I will show you now the activity that you will have to solve. Here's another problem for you to solve this time. Let us now solve your problems in what I can do. Let us first answer item number 1. For item number 1 here, you are asked of the smallest number of carrots that he can equally place in the baskets. Remember that we have 2 baskets. But the first basket, yung mailalagay lang po natin is 75 pieces. Yung second basket po, yung mailalagay natin is 100 pieces. You might be wondering, sir, bakit sa kabila 75, sa kabila 100? Maybe because we do have 2 kinds of carrots. The first one is yung long root. Pag nilagay mo siya dito, syempre 75 lang kasi mas mahaba sila. So mas konti yung mailalagay mo doon. The lesser the number yung mailalagay mo doon kasi mahahaba nga sila. The other one, 100 pieces, because yung other kind of root naman ng farmer natin from Baguio is yung mga medium root lang. So, mas marami yung mailalagay natin dito. Now, pero yung tanong po is the equal number of carrots that can be placed in the basket. So, of course, pag nilagyan mo ito ng 75, another 75, another 75, so ilang basket lahat. Pagkatapos nilagay mo ito ng 100, 100, 100, so ilang basket kaya ang malalagyan mo hanggang sa mag-i-equal yung number ng carrots na maibibenta ng farmer natin. Okay? So, ng kaibigan nating farmer. So, in this case, of course, if you are also observant of the word clues here, the smallest number, so we are looking for the smallest number of carrots na pwedeng maging 75 pieces at saka pwedeng sa 100 pieces. So we are looking for the smallest, and the word smallest is also synonymous from the word least. So we are looking here for the least number where 75 and 100 will meet. So we are looking for the least common multiple or the LCM. Now, after we already identified the solution for this problem, which is the LCM, you will have to look for the LCM of 75 and 100. Now, to look for the LCM, we could use the continuous division. I just want to remind you that we could use divisor here as a prime number if possible. However, pag meron namang hindi prime number pero pwede pa rin nating ma-divide both sa kanila, we could also use that. For example, both are divisible by 25. 75 divided by 25 is equal to 3. 100 divided by 25 is equal to 4. Now, is there still a number that could divide both of them? No more. So, this is already our LCM. So, our LCM is 25 times 3 times 4. 25 times 4 is equal to 100. 100 times 3 is equal to 300. So, that is 300 pieces of carrots. So, that's the solution for our problem number 1. That's 300 pieces. For our problem number 2 in what I can do, you are asked here to find the largest number of seedlings that can be planted equally in rectangular plots. Of course, our given here is 80 sitaw and 120 pechay. Now, you are looking for the biggest number of seedlings that could be planted in each rectangular plot. Of course, what number could we divide 80 and what number could we divide 120 in order for them to segregate them or separate them para hiwa-hiwalayin natin yung pwede nating i-plant sa plot na to. Ito naman yung number of sitaw and pechay na pwedeng i-plant natin sa plot na to. At ito naman yung another set of sitaw and pechay that can be planted here. Remember that we just limit our number of sitaw to 80 and pechay to 120. To what number we could equally divide them? So, if you are also very keen in looking at the problem, we do have a word clue here, the largest number of seedlings. And when you see largest, that is also synonymous to word greatest. Ayan. So dapat titingnan natin yung mga word clues na yan. Greatest. And when we are talking about greatest number that could divide the both of them, we are looking for the greatest common factor. So therefore, the solution for this problem is greatest common factor. So that's the thing that we will have to do this time. So we have to look for the GCF of 80 and 120. GCF. So in order for us to get the GCF of 80 and 120, of course, always remember, we could use continuous division to solve this. And both number are divisible by 10 because they ends with 0. We could use our divisibility rules in order to solve this problem. So this will become 8 and this will become 12. Okay? Both numbers could still be divided by 4. 8 divided by 4 is equal to 2. And 12 divided by 4 is equal to 3. Then there's no more number that could divide them. So here's your GCF. Your GCF here is GCF of 80 and 120 is 10 times 4, which is equal to 40. So, 80 and 120 are both divisible by 40. It simply means that 80 sitaw and 120 petchay are both divisible by 40. So, in one plot, you could plant 40 sitaw and 40 petchay. Because the problem is each kind that can be planted in the plot, so 40 is the answer. 40 seedlings of each kind in every plot. 40 sitaw and 40 petchay. The answer is 40. Good job, grade 5. So I think you are now ready for your assessment. Kindly open your module on page number 8 and answer your assessment. Write this in your pad paper to be submitted the time that we will retrieve your module. However, if you don't have the module with you, I will be showing you the 2 items that you need to solve for our module number 7. Here are the items. With that, I would like to express my thanks to you for joining me in this video tutorial lesson for module number 7. Of course, kita-kita po tayo ulit for module number 8. Bye!